Hey guys, I'm Daniel. Today I'm going to show you around McCLIM, basically some random hacking. I'm one of McCLIM developers. Let's load CLIM Listener. It's available on QuickLisp. And we're gonna use also CLIM Debugger. I don't know about you, but I absolutely hate how Emacs rearranges windows when some new buffer comes in. So when I type error odd, well, it's not bad right now, but if you have more windows and you have carefully arranged them around your workspace, this layout is broken. So one of the things you can do about it, you can wrap your session in CLIM Debugger with Debugger macro. So thanks to that, you will have session which opens new debugger in new window, which is CLIM Debugger. It is not as feature rich as CLIM Debugger, but it's pretty nice. And you can inspect things. In the inspector. So such visualization of data structures and classes is pretty handy when you want to dig into the structure and find what is wrong. If you're interested in debugger, we are accepting pull requests. So okay, and CLIM Listener, which was originally written by Andy Hefner. Looks like ordinary REPL, but in fact it's graphical, so we can draw things on our window. Let's try it. Draw a rectangle on standard output. This is extended stream. You can use it any way you want. You can say format hello world, and it will be printed here, just like in the REPL, but we want to draw a rectangle. Let's start at point from coordinates 300, 300. Let's make it a square, which isn't filled, with line thickness 3 and line dashes true. We'll also make it red, so ink will be red. So right now we have here a rectangle, something what isn't easily achievable on Slime REPL right here. But it may get even cooler because what CLIM, one of the really cool features of CLIM is capability of drawing presentations which map objects on the screen into real objects in the memory. So let's draw this rectangle, but let's draw it as presentation. We'll draw number 42, which is integer. Okay, so right now I can select rectangle with my pointer, and it evaluates into number 42. As you can see, many objects are capable of being clicked, so we can click expression in the listener. In your application, in your own applications, you are not forced to accept anything. You can accept only some stuff. But if you want to accept only integer, then none of this is active. I can click only this little square, and once again it evaluates to 42. We can define commands which specialize on presentations of specific type, and I think that it is a really nice feature which simplifies programming. Some technical details about pane, how we draw it. This stream, which is also a window, is basically a sheet of paper which starts here at upper left corner and extends to the bottom and right. And pane is a subclass of sheet which is used to implement graphical interface primitives. When we draw a rectangle like that, we provide absolute coordinates. So this is point 300, 300. But we may also draw just under the REPL, and we have macro for that, with room for graphics. We will draw arrow here. I will explain this keyword argument in a minute. Oh, and CLIM drawing operations usually come in two flavors. One is without a star, and one is modified with a star. With a star, we provide coordinates alternating x, y, x, y. When we use original function, we need to provide objects of type point. So we have to actually make point 0, 0. Second point, make point 100, 100. Okay. And here we go, debugger. I have probably forgot about some argument. So let's return to application command loop. Draw arrow. Point. Looks okay. Okay, sorry. First argument to with room for graphics is stream, so it will be standard output. And there we go. Arrow, it has some glitch with drawing. And it starts here and grows bottom right. But by default, with room for graphics, except translating drawing to the cursor position, so here, and moving it below drawn image. By default, it also reverse coordinates. So when I draw arrow, it grows like on the chart or some plotting. Of course, we may make line thickness bigger, so this glitch won't be visible. Okay, that looks much better. This could use some anti-aliasing, I suppose. All right. If we don't want to draw on our listener because it takes too much time, we could open Windows stream and draw on it. It's also ordinary stream, well, extended stream. Out. So we can say format out hello world. There we go. Once again, one important note: streams aren't very thread safe. So if we draw very quickly a lot of stuff on them, outside CLIM command loop. I won't describe how it works right now because it would take some time. Some output records may be corrupted. We plan to improve that, so it will be more thread safe. But at the moment, let me show you. 2 times 100 times format out. Okay, bam. As you can see, our output records are corrupted. Output recording is another feature of streams, which also is useful. It basically allows repainting some areas without invoking whole redisplay. We'll clear the window because it is a stream, but it's also a window, and it's clean. All right. Okay. So let's define our first CLIM application. Define application frame. Oh, I should mention that if you want to look for some cool concept of, if you want to look on some function, let's say with room for graphics, you can look it up in CLIM specification. This website is l1sp.org. It allows to look for symbols from various sources like Meta Object Protocol documentation or CLHS, PCL, and in CLIM. So with room for graphics, and it is found. You can read here about this particular macro, what it does. This is a different website. It is CLIM specification hosted by Gilbert Bauman. You can read up about Common Lisp Interface Manager concepts and functions, of course. Pretty useful, especially that it allows annotations like this one, where developers put their remarks about things which are not documented well, or when they are unsure if it is consistently defined with other parts of the system. Okay. So we're gonna define application frame. We'll name it St. Nicolas Day. Define application frame defines class for us, and so it takes like normal class definition, it takes superclass, it takes slots, init arc x, accessor x, and let's do the same thing for y. Alright, and it takes more arguments. We can create panes, and each pane should have a name. So let's call it output. It will be application pane. Application panes are most basic streams to which we can write or draw, just like the window we had earlier. Application. And we'll have interactor. Alright, and another concept, layouts. We can have different layouts for application frames. Let's call this one default. And we'll lay out here vertically output pane, which will take 2/3 of the space, and input, which will take the rest. Compiled without a problem. If run St. Nicolas Day, or celebrate St. Nicolas Day, this function will first it will create our application frame. So set frame make application frame, and we provide symbol here like with make instance. And we'll initialize x to 100 and y to 100. We want to also provide some geometry, so the window won't be overly small. Geometry width will be 800 and height will be 500. All right. And our celebration will start application frame. Run frame top level. And we will do it in new thread. Or not. With debugger, we plan to integrate with debugger macro with application frame definition. We're not sure how it will work, but one possible solution could be adding new option debugger T. Just saying. Okay, celebrate St. Nicolas Day. We'll start it from the listener. Make thread lambda, even not lambda. Celebrate St. Nicolas Day. Bam. Proportions aren't right. Maybe I need to provide proportions also for input. Let's try again. Okay, much better. This is application frame and it shows absolutely nothing. But once again, output is a stream. So if we manage to take the stream from our application frame instance, we'll be able to draw on it. So let's try it. Find pane named. This is a function which takes two arguments, frame and pane name. So frame is named frame and name of the pane is output. Okay, and let's try print something there. Oh, it works. Cool. Right now I want to add some default display function, display method to my frame, because I want to draw something depending on how state of my application changes. So I add display function, which will be called display. It's not defined yet, of course. And let's define method for it. I'm defining it as a generic method because thanks to that I will be able to I'm able to specialize display method display function on different frames and different panes. So I think that this might be pretty useful. Okay. Let's define method. display frame is St. Nicholas Day. This function takes two arguments. First is frame and the second is pane, which is redrawn. We can display output on various occasions. One of them is each iteration of command loop. Commands are basically CLIM functions, which after executing are considered to change state of the application, so things need to be redisplayed. There are other options. You can never redisplay. Basically, redisplaying is clearing out the window and invoking display function at the end of each command loop. We won't gonna specialize pane at the moment. We declare that we ignore frame, and we're gonna draw rectangle starting at position X and Y. Pane once again is a stream. We won't gonna ignore frame because we need it, because it's accessor. Start Y. All right. Start X, start Y, plus start X 100 and plus start Y 100. That should do. And let us define command. Define St. Nicholas Day command. Each application frame has its own set of commands. They can inherit from each other, and we can import commands from other tables. They are called command tables. Our first command will accept two arguments. First will be integer, and second will be integer as well. What we're gonna do is setting X of application frame, this is dynamic variable, to A, and Y of application frame to B. Alright, let's start again. So we have our square. We want to call command foo, that's why we have interactor. It asks for integer. If I had some integer on anywhere in this application frame, I could have selected it, but I don't, so I will provide some different arguments. So it has cleared the window and drawn rectangle once again, depending on frame internal state. Let's modify our display function. So we have some special circles which will allow us to provide arguments to our foo command. Draw circle. It takes center and radius. Okay. So first circle will be drawn at point 100, 100, and it will have radius 30, and its color will be dark green. Let me provide some dummy command, so I will be able to invoke the display on command loop without providing any arguments. The display, we'll put it in menu as well. The display, and it will take no arguments, and it will do really nothing. And here we go. We have called the display, and we'll draw more circles in a row. We'll use for that macro with translation. If I had started a listener in a separate thread, then I would have hints in Slime, but when rep doesn't return, Slime doesn't show hints when you invoke macros or functions. So I'm picking in the listener to see the hints. So it takes medium. Medium may be a stream, because we will extract medium from a stream. Basically, medium is some physical device on which we draw. Streams are something abstract, so it can be divided infinitely, but on medium you actually draw with pixels. So this is some approximation of things we do in our perfect application. So our translation will be we'll draw 5 circles. Do times pane, x will be v 1 plus v times 100, and y will be constant 100. And here we draw a circle at position 0, 0, because this translation sets our coordinate system to things provided here, relatively to the pane sheet. Let's call the display. We have 5 circles, and since we have this v, we want to make them we want to be able to select each circle when we set coordinates of our rectangle in the application frame. Let's draw some text as well. Will it work? No, it won't work. Value of string is 0, which is not of type string. Okay, let's recompile function first. Maybe let's see the actual arguments. Sheet string xy. Okay, that explains everything. And let's try again. It worked, more or less. Okay, so we may try to align align X center and align Y center. By display. So it is nicely centered, and we don't want to print hello. We want to print our number, which this particular circle represents. So it will be V times 100. Is it fine? Format nil. Okay, that should do. The display. All right. And these circles will be integers with output as presentation. Pane object. Object will be this, which is integer. We call it redisplay. Nothing is selectable. We want to change coordinates, starting coordinates of this rectangle. We call our foo command. We could type it in the interactor, but we can also select one of our boxes. So it will start at point 0, and I had to press space here. Interactor needs some user experience improvements. Maybe something I will tackle next. Lately I was working on scrolling improvements, and Y would be 400. And it has scrolled. We have glitch, of course. So let's draw something what is on this area. I think this is pretty cool. Looks like Mickey Mouse. I think that's enough for today's session. So thank you for listening. I invite you to join CLIM channel on Freenode. If you want to talk with me, my nick on Freenode is Jack Daniel. You may write to me at my email. So we are accepting pull requests. We are open for development. Some issues on the repository have bounties on them, so you can make some money on that. And happy hacking. I hope you have enjoyed the video. See you.